Welcome to Session 1 of SAT Nonlinear Systems. Before we touch a single equation, I want you to understand what these problems are really asking. Because once you see it, the algebra becomes almost mechanical. A system of equations is just two rules that have to be true at the same time. And when one of those rules is curved instead of straight, we call it a nonlinear system. That's it. That's the whole idea. Today we'll learn what makes an equation nonlinear, what the solutions actually mean on a graph, and the two-step move that solves almost every one of these problems on test day. First, let's be precise about the word nonlinear. An equation is linear when every variable appears plain, just x, just y, raised to the first power. Something like y equals 2x plus 1. Graph it, and you get a straight line. Always. An equation is nonlinear when a variable does something more interesting. Maybe it's squared, like x squared. Maybe two variables are multiplied together, like xy. Maybe there's a square root, or a variable sitting in a denominator. Any one of those bends the graph into a curve. So here's your quick test. Look for a variable that is not simply raised to the first power. Find one and you're holding a nonlinear equation. Now, the key insight, and this is the one I really want to stick. What does it mean to solve a system? A solution is a point that satisfies both equations at the same time. Not one, both. And on a graph, a point that lives on both curves at once is exactly a point where the two graphs cross. So, solutions are intersections. Intersections are solutions. Those are two ways of saying the same thing. That's why every nonlinear system question is secretly a question about where two graphs meet. Hold on to that, because it explains everything else in this course. Let's solve one. We have y equals x plus 2, and y equals x squared minus 4. A line in a parabola. Here's the move. Both expressions are equal to y, so they must be equal to each other. That's just the transitive property. If y is x plus 2, and y is also x squared minus 4, then x plus 2 equals x squared minus 4. Notice what happened. We had two equations and two variables. Now we have one equation and one variable. That's the whole point of the move. Let's tidy it up. Bring everything to one side, and we get x squared minus x minus 6 equals 0. Factor it. X minus 3 times x plus 2 equals 0. So x equals 3 or x equals negative 2. Now, here is where students throw away points. So listen closely. We found x equals 3 and x equals negative 2. And it is very tempting to stop right here and circle an answer. But x by itself is not a solution. A solution is a point, and a point needs two coordinates. So we go back and find y. Always use the easier equation for this, the line, obviously. When x is 3, y equals 3 plus 2, which is 5. That gives us the point 3, 5. When x is negative 2, y equals negative 2 plus 2, which is 0. That gives us negative 2, 0. And look at the graph. Those are exactly the two places where the line crosses the parabola. The algebra and the picture agree. So how many solutions can you get? When you set a line equal to a parabola, you always land on a quadratic, and a quadratic has at most two real roots. So there are exactly three possibilities. The line can cut straight through the parabola at 2 points. It can graze it at exactly 1 point. We call that tangent. Or it can sail right past and never touch it at all, which means no real solutions. 2, 1, or 0. That's the complete list, and it comes from the degree of the equation, not from how a sketch happens to look. Notice that last case. No real solutions is a perfectly good answer on the SAT. Now let me show you something that will save you real time. A lot of SAT questions don't ask where the graphs meet, they ask for the sum of the x-coordinates, or the product of the x-coordinates. And for those, you never have to find the roots at all. Look at our quadratic. X squared minus x minus 6 equals 0. For any quadratic ax squared plus bx plus c, the roots add up to negative b over a, and they multiply to c over a. Those are Vieta's formulas. Here a is 1, b is negative 1, and c is negative 6. So the sum is negative 1 over 1, which is 1, and the product is negative 6 over 1, negative 6. Check it against our actual roots. 3 plus negative 2 is 1, and 3 times -2 is -6. Perfect match. But we could have read both off the coefficients without factoring anything. There's one more flavor you'll meet constantly. The question gives you the system and asks for the y-coordinate that goes with the greater x value. This one has a trap built right into it. You do the algebra, you find your two x values, you spot the bigger one, and then you get so excited that you circle that x. But the question asked for y. So, our x values were 3 and -2. The greater one is 3. Now substitute into the line. Y equals 3 plus 2, which is 5. The answer is 5, not 3. Read the last 5 words of the question twice. That habit alone is worth points on test day. Let's try one exactly like the ones in your practice set. For the system y equals x minus 2 and y equals x squared plus 4x minus 6, what is the sum of the x coordinates? Set them equal. X minus 2 equals x squared plus 4x minus 6. Move everything over, and you get x squared plus 3x minus 4 equals 0. Now you have a choice. You could factor into x plus 4 times x minus 1, giving roots -4 and 1, which sum to -3. Or faster, Vieta says the sum is -b over a, which is -3 over 1. -3. Same answer, half the work. The answer is C. And notice the distractors are doing exactly what you'd expect. -4 is the product, and 5 is the difference. Every wrong answer is someone's real mistake. Let's pull it together. Nonlinear means some variable is not just to the first power. Usually, it's squared. A solution is a point that works in both equations, which is the same thing as an intersection on the graph. To solve, set the two expressions equal. Collapse to one quadratic and solve it. Then, back substitute to get the y-coordinate, because a solution is an ordered pair, not a lonely x. A line and a parabola can meet twice, once, or never. And if the question only wants a sum or a product of roots, use Vieta and skip the factoring entirely. Nice work on session 1. You now know what these systems mean, what the solutions represent, and how to get them without losing coordinates along the way. In session 2, we'll go deeper into substitution, including what to do when the equations aren't already solved for y, and how to recover the second coordinate cleanly every single time.